Good afternoon to all of you. This is Somshekar, Assistant Professor of Mathematics, Saramvi Government Science College, Mamunkatte, Bhadravati. Welcome to my second session of Differential Equation chapter under the unit Total Differential Equation. In the previous session, we learned how to test the integrity condition for the given total differential equation. In this session, we are going to learn how to solve the total differential equation by treating one of the variable as a constant. Of course, this will be the session outcome and also session summary. Before going to this session, we need how to find the partial derivatives and the integrity condition of the equation p dx plus q dy plus r dz equal to 0, and we should know how to solve the first order first degree differential equation. We have studied this in the previous semester. Let me come to the main content. We already know this. The integrity condition of the equation p dx plus q dy plus r dz is equal to 0 is p into del q by del z minus del r by del y plus q into del r by del x minus del p by del z plus r into del p by del y minus del q by del x is equal to 0. To solve this equation, consider any one of the variable among x, y, z as a constant and then solve. Let me go through some illustrations. Verify the integrity condition of the equation x square plus y square plus z square into dx minus 2xy dy minus 2xz dz equal to 0 and solve. First, consider the given equation, call it as 1. Now we have to test the integrity condition. For this, write down p, q, r values. And we already know p is the coefficient of dx, that is x square plus y square plus z square. Q is the coefficient of dy, which is minus 2xy. And capital R is coefficient of dz, and this will be minus 2xz. Now del p by del y is, find these values. Del p by del y is equal to partial differentiation of p with respect to y, and that means we have to differentiate p with respect to y, keeping x and z are constants. Here x and z are constants, so x square and z square term becomes vanishes after differentiation. Y square na derivative of 2y. Similarly, del p by del z is equal to, with respect to z ಇದೆ, x and y are constants. These two become 0. Z square na derivative of 2z. Del q by del x is equal to q na derivative with respect to x. Y is a constant, minus 2 is a constant, minus 2y into x na derivative 1, no? Minus 2y into 1 minus 2y. Del q by del z is equal to, with respect to z ಇದೆ, x ಮತ್ತು y constant. 2xy constants. This term is a constant term, so the derivative will be 0. Del r by del x is equal to, with respect to x ಇದೆ y ಮತ್ತು z constant, minus 2z, it's a constant. X na derivative with respect to x ಅಂದರೆ 1 ಆಯಿತು, minus 2z into 1 minus 2z. Del r by del y is equal to, with respect to y ಇದೆ x ಮತ್ತು z constant, x z constant to 2 constant, and this is a constant term, so the derivative will be 0. Consider p into del q by del z minus del r by del y plus q into del r by del x minus del p by del z plus r into del p by del y minus del q by del x. And this is an integrability term. Apply the respective values. Here p is x square plus y square plus z square into del q by del z is 0 minus del r by del y is 0 plus q into q is minus 2xy into del r by del x del r by del x is minus 2z, minus of del p by del z is 2y, minus 2, del p by del z is 2z minus 2z, plus r into r is minus 2xz into del p by del y. Del p by del y is 2y, minus of del q by del x is minus 2y, minus of minus 2y, it will be positive of 2y. Now 0 into something will be 0, minus 2z minus 2z minus 4z, minus 4z into minus 2xyz, minus 4 into minus 2 plus 8 xyz, 8xyz, and this is 4y, plus into minus minus, 4 into 2 8, 8 into xyz. Now positive of 8xyz, negative of 8xyz gets cancelled. The value will be 0, and therefore the given equation is integrable. Now it is a time to solve this equation. The method is, we have to consider any one of the variable among xyz is a constant. The question is, which variable I have to take as a constant. ಈ ಮೂರರಲ್ಲಿ ಯಾವ ಟರ್ಮು more than one term ಇದೆಯೋ, which term contains more than one term, please try to vanish that term. Here this first term contains more than one term, so try to vanish this term, and this term becomes 0 only when dx is 0, and dx is 0 only when x is constant. So if x is constant, then only dx becomes 0, and therefore treat x as constant. That x is equals to constant, this implies the derivative will be 0, differential will be 0, dx is equal to 0. Now when dx is equal to 0, the equation 1 becomes, when dx is equal to 0, the equation 1 becomes minus 2xy dy minus 2xz dz is equal to 0, and divided by minus x, we get 2y dy plus 2z dz is equal to 0, and this term 2y dy plus 2z dz is equal to 0. Integrate both sides. We have y in the integration of y square by 2. Now 2 gets cancelled, it will be y square, plus z in the integration of z square by 2. 2 gets cancelled, it will be z square, is equal to constant of integration. Now take the constant of integration as function of x, because here x is constant, therefore any term in x is also a constant. That means the function of x is a constant. So take the constant of integration as this constant f of x, function of x. Y square plus z square is equal to f of x. Call this as 2. And differentiate totally on both sides. We have y square in the differentiation of 2y dy plus z square in the differential of 2z into z in the differential dz equal to f in the differential of f dash into x in the differential dx, f dash of x into dx. Now this implies multiply by x. Why we have to multiply by x? Please bring this equation in the format of first equation. In the first equation we have minus 2xy dy minus 2xz dz. But we only have 2y dy 2z dz. Here x is, here there is a deficiency of x, and therefore multiply by x. Here I am trying to bring this equation in the first equation format, that's all. For that, here there is a deficiency of x when compared to the first equation, so multiply by x. X into f dash of x into dx. Bring these two terms to right hand side. Now positive becomes negative. Minus 2xy dy minus 2x minus 2xz dz equal to 0. Call this as 3. Compare 1 and 3. Compare 1 and 3. These two terms, the second terms are same. There is a difference in first term. Comparing 1 and 3, we have here the coefficient of dx is x square plus y square plus z square. In place of x square plus y square plus z square, we have x into f dash of x. Comparing 1 and 3, we have in place of x into f dash of x, we have x square plus y square plus z square. Equate those two. X into f dash of x is equal to x square plus y square plus z square. X into f dash of x is equal to x square plus my y square plus z square is function of x. Y square plus z square is y square plus z square. Y square plus z square is f of x. So in place of y square plus z square, it will be f of x. Replace y square plus z square by f of x. X into f dash of x is equal to x square plus f of x, and divide by x, f dash of x, and this is x square by x is x plus 1 by x into f of x. Bring 1 by x into f of x to left hand side. We have negative of 1 by x f of x is equal to x, and this is the first order linear differential equation. We already know how to solve this type of equation in the previous semester. By previous semester knowledge, solve this equation. After solving this equation, we have the solution of this equation as f of x is equal to x square plus cx. Again, put the value of f of x. F of x is y square plus z square. So y square plus z square is equal to x square plus cx, and which is the required solution. Let me go through the second equation. Verify the integrity condition of the equation of this equation and solve. Consider this equation as 1. We already know how to test the integrity condition. Please go through the integrity condition. I skip this because we already know this. I directly go to the solution of this equation. Here, the third term contains more than one term, so try to vanish this term. This term vanishes when dz is equal to 0, and dz is equal to 0 when z is a constant. Therefore, treat z as constant. Let z is equal to constant, the differential of z is 0, dz is equal to 0. When dz is equal to 0, the first equation take this form. Yz square dx minus xz square dy is equal to 0. Divide by z square, we get y dx minus x dy is equal to 0. Divide by x square on both sides, y dx minus x dy by x square is equal to 0 by x square is 0. And this is the format of differential of y by x. When you differentiate y by x, we have this format. We already know how to differentiate this using quotient rule. Y into the differential of y by x and differentiation of y into the differential of denominator dx minus x into the differential of numerator dy divided by denominator square x square. So exactly this is the format of differential of y by x. d of y by x is equal to 0. On integrating, we have differential integration cancel ಆಗುತ್ತೆ. Y by x is equal to constant of integration. Now take the constant of integration as f of z, because z is a constant and any term in z is also a constant. That means function of z is a constant. So take the constant of integration as f of z. We have y by x is equal to f of x. Differentiate totally on both sides. Again, y by x differentiation, we already know this. Y dx minus x dy by x square, and these vice versa. Y dx minus x dy by x square is equal to f of z na differentiation of f dash of z into z na differential dz. Now y dx minus x dy divided by x square in the corresponding multiply y dx minus x dy is equal to x square into f dash of z dz. Multiply by z square. Why we have to multiply by z square? Because I am trying to bring this equation to first equation format. In the first equation, we have yz square dx minus xz square dy. But we only have y dx minus x dy. And z square is, there is a deficiency in z square to bring that equation to first format. So multiply by z square. Multiplying by z square, we get yz square dx minus xz square dy equal to x square z square f dash of z dz. Call this as 3. Compare 1 and 3. In place of x square z square f dash of z, we have 2xyz plus x square. So comparing 1 and 3, we have x square z square f dash of z equal to 2xyz plus x square. Divide by x square, z square f dash of z is equal to x square na divide ಮಾಡಿದೀವಿ, divide by x square, 1x cancel ಆಗುತ್ತೆ, 2yz by x plus x square by x square is 1. Z square f dash of z is equal to 2z into replace y by x by f of z. My y by x is f of z by second equation. So replace y by x by f of z. 2z f of z plus 1 divided by z square f dash of z equal to z square in the divide ಮಾಡಿದೀವಿ, 2 by z f of z. Bring this to left hand side. Negative of 2 by z f of z is equal to 1 by z square, which is, and this is the first order linear differential equation. By using previous semester knowledge, solve this equation. After solving, we get the solution as f of z is equal to minus 1 by 3z plus cz square. Now replace f of z by y by x. Y by x plus negative of 1 by 3z negative is a positive of 1 by 3z is equal to cz square, which is the required solution. There are some exercise problems. Please work out these problems. Still, if you have any doubt, please go through these references. Thank you one and all.